We pick them up right here. Examples of different theta values. So we're going to be solving harder trig equations today. And we start with 4 sine of 2/3 theta plus 2 is equal to 0. What do you think I do first? We're good to go so far. 4 sine of 2/3 theta is equal to -2. Now what? Divide by 4. 2/3 theta, or I'm sorry, sine of 2/3 theta is equal to -1/2. What do you think is the mistake that people might make right now? What do you think they might be tempted to do? Multiply by 3/2. And you can't do that. Before you deal with the 2/3, you have to get rid of sine. How do you get rid of sine? Sine inverse. So we will sine inverse to get rid of sine. And that requires me to set up my quadrants. Where is sine negative? Which quadrants? The third and the fourth. Very good. And because you're really smart, you've memorized where sine is equal to 1/2. What is my reference angle? 30 degrees. If you didn't know that, you can do that on your calculator. So now that I've done that, I can remove sine. I just did sine inverse, so sine is gone, and I have 2/3 theta is equal to, what is my first angle? 210 degrees. And what is my second angle? 330 degrees. So now is when I get rid of the 2/3. What do? Multiply by the reciprocal, or 3/2. 3 times 210 is 630, divided by 2 is 315. 3 times 330 is 990, divided by 2 is 495. Not too bad, huh? Okay. All right, any thoughts for the next one? Get them on the same side, and then we'll take out a cosine. So 2, yeah. Oh, yes, I'm sorry. Thank you for pointing that out. Technically, only one of these satisfies the initial condition, right? I'm not going to make you go back and change that. What I will do, just for the sake of time, we don't have quite enough time to deal with all those type of situations. I will be making sure that when you do this part, that you're coming up with theta between 0 and 360, okay? But as far as your end results, that's a little bit more involved. And actually, in the mathematical community, we have ways of kind of working around it. So this one we have time to donate to all of it. So I would like your initial setup to be between 0 and 360. So don't worry about getting rid of the last one, okay? Good question. 2 cosine squared of theta minus cosine of 3 theta is equal to 0. And then Emma said to factor out, whoops, forgot the 3 there. I said to factor out a cosine of 3 theta. And when you do, what are you left with? 2 cosine of 3 theta minus 1. So you leave the angle alone, okay? Don't, yeah, just leave the angle alone. So we set both these up. Cosine of 3 theta is equal to 0, and cosine of 3 theta is equal to 1/2. Where is cosine equal to 0? 90 and 270. Remember, the x value is 0. So we have 3 theta is equal to 90, and 3 theta is equal to 270. Therefore, theta is so we thought about the unit circle, and if cosine is equal to 0, that occurs wherever the x value is equal to 0, and that occurs at those 2 spots. Better? Okay, so as I go back, Theta is equal to 30 and 90. Okay, now I have this second part to deal with. Does anybody know? Well, cosine is positive. In which quadrants is cosine positive? 1 and 4. Anybody remember the exact value of cosine is equal to 1/2? 60. 60 is our reference angle. So therefore, 3 theta is equal to 60, and 3 theta is equal to 300. Divide by 3 and we get 20 and 100. So there are my 4 solutions. Plug it all back in. Oh, to sure know about the right number. If it's a squared, it's a good shot. There's 4. Might be 5. Might be 3. Well, how about this? If it's a squared, you only get 2. You probably you might want to recheck your work. Okay. All right. So, when I was taking this test in high school, I was overconfident, and I was so mad when I got that test back. My teacher was disappointed too, because he had told me. I just didn't listen. But I got this one right. I divided by cosine. Like, wait, you just told us not to divide by cosine. Now you're dividing by cosine. Yes. Yeah. We get negative root of 3 is equal to tangent. Here's the difference. In the previous problem, if you divide by cosine, you actually reduce the power of the original problem, which means you risk losing solutions. But did I reduce the power? No. Did a cosine cancel? It's simply just, the cosine's still there. It's just all caught up in the tangent, right? So I just rewrote it, all right? It's still there, okay? It's still there. So, where's tangent negative? Second and fourth. Anybody know what the tangent inverse of the root of 3 is? $60. Very good. Therefore, x is, there are 2 solutions. 20 and right. So this one was an example where we convert to other trigonometric functions. So you can see that you have a sine and a cosine. Factoring didn't work, but rewriting in terms of tangent did. You can see in this one I have a cosecant and a sine. Any thoughts? One over sine. Okay, let's do that. And just so you guys understand, there's multiple ways to do this problem. We're going to roll with Kayla's thought. Thought now? Okay, common denominators. If I wanted to add or subtract them, but sure, how are you going to get them on the same side? Cross multiply. 1 times 1? 1. And this will be 2. What's sine of x over 2 times sine of x over 2? Sine squared of x over 2. Now I don't have a cosecant anymore. Cosecant's gone. It's all tied up in the sine. So now what? Divide by 2. And I get 1 over 2 is equal to sine squared of x over 2. What do I have to get rid of now? squared, so I take square root. And after this, plus or minus the root of 1/2 is equal to the sine of x over 2. Now what do I have to get rid of? Before I deal with the x over 2, I have to get rid of the sine. How do you get rid of sine? Sine inverse. So I set up my quadrant. Sine inverse. Where is sine positive? 1 and 2, negative in the third and the fourth. Ooh, super smart. What's the sine inverse of the square root of 1/2? 45. Did you know your calculator? Did you know it? Okay, that's all right. We just and that's impressive too. I mean, you know, I just like the way you said it. We were like, boy, she like figured it out like that. Okay, all right, okay, all right. Well, thank you for being honest. Good time out here. All right. So, okay, so we got kind of caught up in the whole square root of 1 over 2. What do I write down? Okay, what goes on the other side of the four solutions? X over 2. X over 2 is equal to, what's my first one? 45. And then x over 2 is equal to 135. And then x over 2 is equal to 225. And then x over 2 is equal to 315. So now what do I have to do to each of these? Multiply by 2, and I get x is 90. X is 270. X is 50. 630. And obviously not all these fall between 0 and 360. I just want your original setup for sine inverse to fall between 0 and 360. Fair enough? You still hanging in there? Oh, listen to that. She's like, we're fine. Like, bring on the difficult stuff. All right. I will. What? Prince is dead? How? Okay. All right. All right. Well, we'll do this next problem for Prince. Okay, this is a memory of Prince. Well, we will. Oh, I'll play Purple Rain after this or something. Okay. All right. Okay, we'll play Thieves in the Temple or Diamonds and Pearls. Raspberry Beret. Little Red Corvette. 1999. All right. Here we go. What makes this problem more difficult than the others? There's two things. There's a sine and a cosine. Good. We've dealt with that before. This causes even bigger issues. What else up here causes even bigger? Yes. You have a 2x and a single x. These are non-reconcilable issues. You cannot have a 2x and an x. They won't work together. You can't have a double angle and a single angle. Oh goodness, if only we had a sheet of notes that would tell us how to convert a double angle to a single angle, then I would have somewhere to go and something to do. Not half angle, I'm looking for a double angle to convert to a single. Got it. So, sine of 2x is actually the same thing as 2 sine of x cosine of x minus the cosine of x. Now, the problem is easy peasy. Factor out the cosine, we get 2 sine of x minus 1 is equal to 0. So now I set up two equations. What's my first equation? Cosine of x equals 0, and we've actually done both of these already, haven't we? It's kind of nice. You're like, hey, I remember those answers. X is 90 degrees, 270 degrees. And then sine is 1/2. Positive in which quadrants? 1 and 2. Inverse, sine of 1/2. 30. My two angles are 30 and 150. What up, G? We're just talking about you. All right. Ready for the last one? Okay. Initial thoughts. I subtract sine, they'll all be on one side, but will I be able to combine any like terms? No. Does anything have a common factor? No. How about if I divide through by cosine? What's cosine over cosine? 1. And then what's 1 over cosine? Secant. And then what's sine over cosine? Well, that doesn't really help me either, does it? If I divide by sine, I'll get cotangent plus cosecant is equal to 1. That's not really helpful either, is it? It's asking us a question. It's begging an answer. And it's saying cosine of x plus 1 is equal to sine. Where does that happen? Think about it, guys. Okay? Just think about it. Sine starts here and goes up, right? And then cosine starts up here and it goes down. Like, there are some points where these things are going to intersect. But the question is, how do we find it? Ryan? Yes. Square them. Now, we got to be careful. If you square both sides, you run a risk of adding solutions. But it's a risk we're willing to take. Dangerous mathematics right here. We get cosine squared of x plus 2 cosine of x plus 1 is equal to sine squared of x. Hey, they're all single angles. If only I didn't have a sine squared. Excellent statement, but we're going to change it around a little bit to make better use of it. We're going to say that cosine squared of x plus 2 cosine of x plus 1 is equal to, instead of writing sine squared, we write 1 minus cosine squared. What happens to the 1's? What do you do with the negative cosine squared? To get a 2 cosine squared. Factor out a 2 cosine. That was awesome. All right. Okay, here we go. All right, what's up? What we got? Plus 1. So we've got 2 cosine of x is equal to 0, or cosine of x is equal to 0. And we've got cosine of x will be equal to negative 1. Everybody concur? So, the big question, where's cosine of x equal to 0? We already answered that twice before, so 90 and 270. Where's cosine equal to negative 1? 180. It's equal to 1 at 0 and 360 because it's positive over there, negative 1 over on the other side. And so we're done, right? Why? We might have added solutions. It was a risk. We were willing to take it. How do we check to see if we did or not? We plug them in. That's all we can do. We try 90. And we try 270. And we try 180. What's the cosine of 90? 1. Or no, 0. Plus 1 is 1. What's the sine of 90? Did 90 work? Try 270. What's the cosine 270? 0. Plus 1? What's the sine of 270? Negative 1. Did that work? No. Try 180. Cosine of 180. Negative 1 plus 1 is 0. Sine of 180? 0. Did that work? Yes. So our answers are 90 and 180. Good work. It was an exciting day. No, they were the same problems. I messed the notes up. So, hey guys, just be forewarned, okay? This is your assignment, and I say to choose 4 out of these 7. Yeah, it's just harder problems. And I say choose 4. This is up to you guys. You gotta at least try 4. You get all 4, do all 7. It's up to you how much you want to prepare. The fact is that some of these problems are hard. And if you feel like you can't do some of them, you probably got other people feeling the same way. What day's test? Tuesday. What do you have tomorrow? Workday, study guide. What do you have Monday? Workday, study guide. Test on Tuesday. Okay?